All right, let's just dive right in. What really happens if you fall into a black hole? For decades, we've all heard the same terrifying story, right? This process called spaghettification, which is a colorful way of saying you get stretched into oblivion. But what if that's completely wrong? What if instead of being an ending, a black hole is actually a beginning? So let's talk about it. The crucial moment is when you cross the event horizon. That's the literal point of no return. Once you're past that invisible boundary, everything we thought we knew about physics just gets turned on its head. So, what is your ultimate fate? For the longest time, the answer seemed pretty simple and, frankly, terrifying. You'd be stretched and squeezed by those insane gravitational forces, yep, spaghettification, and ultimately crushed into a point of infinite density. Game over. But what if that's not the full story? What if the end of your journey in this universe is just the start of a brand new one? To really get our heads around these new mind-bending ideas, we first need to take a look at the classical picture. You know, the old-school, horrifying view of what's waiting for you at the center of a black hole. Okay, so according to Einstein's theory of general relativity, right at the heart of every black hole, there's a singularity. Just think of it as the universe's ultimate dead end. It's a point that is so unbelievably dense and so tiny that space-time itself just collapses. And all the laws of physics we know and love, they just stop working. Now, for decades, this singularity has been a huge problem for physicists. It's this one place where our two greatest theories of the universe, general relativity and quantum mechanics, basically just get into a fistfight. They violently disagree. It's like a cosmic glitch in the system where our understanding of reality completely breaks down. But that raises a massive question. What if this point of breakdown, this glitch in our theories, isn't actually a feature of the universe at all? What if it's just a giant signpost telling us that our understanding is incomplete? And this is where things get really exciting, because this illustrates a massive shift in thinking. Some really recent research suggests it's actually possible for black holes to form without these infinitely dense singularities, using nothing more than the pure force of gravity itself. That cosmic glitch, it might not even be real. So, if a black hole isn't a one-way trip to oblivion, what could it be? This is where the story takes a truly fascinating turn, transforming these cosmic destroyers into potential creators. This leads us to this incredible new model called black hole cosmology. And this theory proposes something that is just staggering, that our entire observable universe, everything we see, everything we know, might just exist inside a black hole that formed in some other, larger parent universe. I mean, think about that for a second. Our Big Bang could have been someone else's black hole. So how would that even work? Well, in this model, matter doesn't get crushed down to infinity. It starts its gravitational collapse, sure, but instead of hitting a dead end, it hits a maximum possible density. It just can't get any smaller. And then it bounces. They call it a big bounce. And that bounce triggers a rapid, massive expansion, an event that, from the inside, would look exactly like a Big Bang, creating a brand new baby universe. And this whole idea of baby universes, it's more than just a wild origin story. It might also provide a beautiful solution to one of the most profound and frustrating paradoxes in all of physics. So what is the information paradox? Well, it's a fundamental clash. On one side, you've got Einstein's general relativity, which says that any information that falls into a black hole is destroyed forever, deleted, gone. But on the other side, you've got quantum mechanics, which has one absolutely strict rule. Information can never be lost. So who's right? Where does it go? Now, scientists have come up with some pretty wild ideas to solve this, like fuzzball theory or firewall theory. They sound like something straight out of science fiction. But the baby universe theory offers a stunningly elegant answer. It says the information isn't destroyed, it's simply transferred. It escapes into the new universe that gets created on the other side. This leads us to an implication that is so profound, it forces us to reconsider the most fundamental thing we experience every single day, the forward march of time. So here's the crucial point. If information moves into a baby universe, how does it get there? The physicist Sabine Hossenfelder puts it pretty bluntly. The information doesn't just cross a boundary in space, it crosses a boundary in time. In this new picture, time doesn't hit a dead end inside a black hole. Instead, think of it more like a mirror. For every little piece of information that goes in, moving forward in time, it's paired with another piece that comes out, effectively moving backward in time. The singularity is no longer a wall, it's a reflection point. It's a bridge between the future and the past. And that just challenges our entire perception of time as a one-way street. And that leaves us with a final, really provocative thought. For a century, we've seen black holes as the universe's final resting place, the ultimate symbol of an ending. But perhaps we've had it all wrong. Perhaps these cosmic titans are not the end of the story, but the very place where new universes, new realities, and new timelines are born.